Hello, 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 and welcome back to the stream. Today is Coding Friday. I've actually been looking forward to this because I miss coding. And since I really enjoy games, like getting back into learning how to do game development is it's kind of like a passion of mine. So I'm really excited to do this. So, as a quick refresher, from last week, we went through the entire Your First 2D game from the Godot docs, built that out, and this is the example. I pulled it up right here. So, go ahead and run it again. Hit the start button. Got this little guy looking around. Got the animations, the timer at the top. I hit the game over, and it starts again, and it resets. So that's all working. So that was our first game that we created last week through the tutorial and documentation. That actually took us about 3 hours. I was going a little bit slower than I normally would because I was actually reading just about everything in the docs. Usually I would just skim a lot of it as I was going through it, but I wanted to make sure that I read it here on the stream. But yeah, I'll go ahead and close that. I went ahead and tried to do a little bit of prep this time before we got started. So this is your first 3D game. Here's the example of it, which is essentially the same type of game, except instead of trying to avoid it, you can actually jump and squash the little creatures, which is kind of cool. So still kind of like same look of the things. Not as much animation on 3D characters, but I think that still looks pretty good. So as we're going through here, sorry, I keep saying I need to when I do the highlights on this, I'll need to cut those out. Anyway, yeah, here it said to go ahead and download the creep assets. So when I click on this, it brings us straight to the Godot engine GitHub. And here you can download the actual source code. So the entire thing's already built. Or you could just grab the zip file for the starting of the project. Now, the starting of the project starts off in 3.x. So the Godot engine has been updated to 4. So when you import it, so right here, when you're on this screen and you hit that import button, you have to go to the correct place first. For some reason, it automatically goes to OneDrive, and I can't find a way to change the default path. I have no idea how. But anyways, I have it here. So you go in here. After you unzip the file, you go in here, and then you double click on the project Godot, and it'll pop up with a warning about it being a 3.x game. Excuse me. So then you have the option to convert the project file to 4.3, or you can convert the entire project, like all the assets and everything, into 4.3. So I clicked on convert the entire project. It does mention that in the documentation. I just wanted to mention that before we get to it so I don't have to reread that entire part. So we have everything open right now. Here are the art assets right here and the fonts that were brought in. And so we are pretty much ready to get started. I'll go ahead and read through the beginning right here. That way we have our little introduction. So in this step-by-step tutorial series, you will create your first complete 3D game with Godot. By the end of the series, you will have a simple yet finished project of your own, like the animated GIF below. Your game, the game we'll code here is similar to your first 2D game with a twist. You can now jump, and your goal is to squash the creeps. This way, you will both recognize patterns you learned in the previous tutorial and build upon them with new code and features. So the things that we're going to focus on are, sorry, something stuck in my throat. Work with 3D coordinates with a jumping mechanic. Use kinetic bodies to move 3D characters and detect when and how they collide. Use physics layers and a group to detect interactions with specific entities. Code basic procedural gameplay by instancing monsters at regular time intervals. Design a movement animation and change its speed at runtime. Draw a user interface on a 3D game. Okay. And more. Well, there's always more. On a side note, I did check out a couple other videos on YouTube about Godot because there were some things that I was interested in learning. And it should help when we decide to start building our own game in this engine. And once that happens, I will be posting the source code and everything like that on Patreon. So if you sign up for my Patreon, that'll all be available for you. I just kind of want to build games and get it out there. But I also need to make a living some way. And Patreon seems to be the way to do it right now. Unless I can find a way to add space on the game, because I hate games that take up 30 to 45 seconds every single time you finish one thing in it. And you can't do anything about it. Anyway, let's see. Moving on, prepare the game assets. We will work with the basic prototypes of movement. All right, getting set up. All right, so this is that entire section that I just mentioned, doing the conversion. So now here we are with the arts, fonts. There are two 3D models, player.glb and mob.glb. That's here and here. Some materials that belong to these models and a music track. Setting up the playable area. We're going to create our main scene with a plain node as its root. In the scene dock, click the Add Child Node button, represented by the plus icon in the top left, and double-click on Node. Name the node Main. An alternate method to rename the node is to right-click on Node and choose Rename or F2. Alternatively, to add a node to the scene, you can press Control-A or Command-A on Mac. All right, so we're doing a as root. Click that one. Yep. And then click that node. All right, let's try the Control-A. Ah, okay, cool. Create that, and then F2 for rename, and main. Cool. Save the scene as main.tsn. Okay, Control-S. We'll start by adding a floor that'll prevent the character from falling. To create static colliders like the floor, walls, or ceiling, you can use static body 3D nodes. They require collision shape 3D child nodes to define the collision area. With the main node selected, add a static body 3D node, then a collision shape 3D. Rename the static 3D to ground. So as an example, we're looking right here. Static body 3D. Okay. So here, static body 3D, create, and then we need a collision shape 3D. Okay. And then we need to rename the static body to ground. Okay, so we got that. Okay, there's no shape to it or anything like that right now. All right, your scene tree should look like this. Hey, Prismatic Queen. Thank you so much for the follow. I really appreciate it. Sorry, you made me lose my train of thought. Let's see. Your scene tree should like this. A warning sign next to the collision shape 3D appears because we haven't defined its shape. If you click the icon, a pop-up appears to give you more information. So if you click that, it gives you the actual warning. All right. To create a shape, select the collision shape 3D node, head to the inspector and click the empty right here field next to the shape property and create a new box shape 3D. That one. Okay. So now we have a box shape 3D. Yeah, okay. All right. Now moving on. The box shape is perfect for flat ground and walls. Its thickness makes it reliable to block even fast-moving objects. A box wireframe appears in the viewport with 3 orange dots. I see a lot more than 3. You can click and drag these to edit the shape's extents interactively. We can also precisely set the size in the inspector. Click on the box shape 3D to expand the resource. Set it to 60 on the x-axis, 2 on the y, 60 on the z. Where is it? So right here. So we want 60 meters, right? And it said 2, all right? Just so we have... By the way, I'm holding down the middle mouse button to move around the camera like this. Okay, and then it says 60 on Z. All right, so that gives us a platform, basically, to work with. Okay. Collision shapes are invisible. We need to add a visual floor that goes along with it. Select the ground node and add a mesh instance 3D as its child. Mesh and can't spell. Mesh instance 3D. Create. In the inspector, click on the field next to mesh and create a box mesh. Okay, right here. New box mesh. To create a visible box. There it is. And once again, it's too small by default. Click the box and make it expand to the same size. Okay. So it was 60 to 60. Ooh, sorry. Okay, so now this actual mesh is the exact same size as the collision box. You should see a wide gray slab that covers the grid and blue and red axis in the viewport. Oops. Didn't mean to move that. Something like that. Anyway, let's see. What are we going to do? We're going to move the ground down so we can see the floor grid. To do this, the grid snapping feature can be used. Grid snapping can be activated 2 ways in the 3D editor. The first is by pressing the Use Snap button or pressing the Y key. The second is by selecting a node, dragging a handle on the gizmo. This is a gizmo, by the way. Oh, sorry, this is a gizmo. Or this. I think they're both considered gizmos. Then holding control while still clicking to enable snapping as long as control is held. Okay, so if I hold control, oh, it does snap. Snap, 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 snap. Okay. No. Okay, so this is the gizmo they're talking about. This is changing my camera view. Let's see. Y button. Group selected nodes. Where's the snap? Use snap. Okay. So if I do Y, that's that. And then we snap it. Now, it is just below the grid, right? Yeah. Perspective wise, it kind of at a distance, it looks like it's below the grid, but you really get down to it, like at the level, you can see that it's at the grid level. Right? What's throwing me off is this blue line right here. Oh, wait. Okay, the blue line is the collision. I did that wrong. I need to select that and then do that. Okay. I selected just the mesh and moved it. I need to select the entire grouping, which is the ground, so they move together because they're linked. Okay, that's better. All right, now they're in there. Start by setting snapping with your preferred method, then move the ground node using the y-axis, the green arrow on the gizmo. Okay, move the ground down 1 meter. In order to have a visible editor grid, a label in the bottom left corner of the viewport tells you how much you're translating the node. What? I must have missed that. Oh, okay. So when I was here, and then I move it down because it says -1. All right, cool. Ultimately, ground's transform position dot y should be -1. Yeah, okay, whatever. Let's add a directional light so our scene isn't all gray. Select the main node and add a child node called directional light. Okay. We need to move and rotate the directional 3D node. Move it up by clicking and dragging the manipulator's green arrow. Click and drag on the red arc to rotate it around the x-axis until the ground is lit up. Okay. And then that arrow is the direction of the light, so I won't point it straight down. Maybe? Unless I want it to have a little bit of shadow. Um, Yeah, let's do it like at an, no, let's just go straight down with it. All right. Then it says inspector turn on shadow enabled. Shadow enabled on. At this point, your project should look something like this. Okay. Well, I mean, a little bit. They have it at an angle a little bit. Closer. I'm trying to match it like almost exactly because if I screw it up, I want it to be the tutorial's fault, not mine. So we're looking at it kind of like that. There. Okay, we'll go with that. All right. So that's our starting point. In the next part, we will work on the player scene and base movement. All right. Player scene and input actions. In the next two lessons, we will design the player scene, register custom input actions, and code player movement. By the end, you'll have a playable character that moves in 8 directions. Create a new scene by going to the scene menu in the top left and clicking new scene. Or, first off, I'm going to save this. Oops, wrong button. Save it. You can also just click this, and that'll add new scene. All right, so then we hit other node and create a character 3D. Character 3D. And this is going to be named player. Character bodies are complementary to the area and rigid bodies used. Complementary to the area and rigid bodies used in the 2D game tutorial. Like rigid bodies, they can move and collide with the environment, but instead of being controlled by the physics engine, you dictate their movement. You will see how we use the node's unique features when we code the jump and squash mechanic. For now, we're going to create a basic rig for our character's 3D model. This will allow us to rotate the model later via code while it plays an animation. Add a 3D node as a child of player named Pivot. All right, so we need a node 3D. So just this. And they said name it Pivot. Every single time I hear Pivot, I just think of Friends. All right. And then in the file system doc, that's down here, expand the art folder by double clicking it and drag and drop the player.glb onto Pivot right here. Ooh, that made it big. That's our player. That's kind of cool. This should instantiate the model as a child of Pivot. You can rename it to character. Okay. The I'm just gonna read this note because I didn't kind of curious what a .glb is. The .glb files contain 3D scene data based on the open source GLTF 2.0 specification. They're a modern and powerful alternative to proprietary format like FBX, which Godot also supports. To produce these files, we designed the model in Blender 3D and exported it to GLTF. As with all kinds of physics nodes, we need a collision shape for our character to collide with the environment. Select the player node again and add a child, collision shape 3D. And then the shape is going to be a sphere shape. Okay. The sphere's wireframe looks. Okay, the sphere's wireframe appears below the character. It will be the shape the physics engine uses to collide with the environment, so we want it to better fit the 3D model. Make it a bit larger by dragging the orange dot in the viewport. My sphere has a radius of about 0.8 meters. Then move the collision shape up so its bottom roughly aligns with the grid's plane. Okay. We want this to be bigger. This is move, R for scale. What's the error here? Okay, I didn't do that properly. All right, let's just look at this. I'm going to turn off snapping. Back there. Okay, can I scale it? Let like transform. Hmm. The orange dot. Where are the orange dots? Is that it? Yeah, okay, so that's the orange dot. Transform position, rotation, scale. So to 0.8. Bring it down. We can hide the character for a moment. And that'll allow us to do that. Do that with snapping to grid, do it. Yeah, okay, snap to grid worked. Then we open that up. Okay, to make the shape easier, you can toggle a model's visibility by clicking the eye icon next to the character or pivot nodes. Save the scene. Is it me or does that collision box seem really small? Are you supposed to move the character up? I think we were. Oof, didn't like that. Let's go back down. Bring it down a little more. Okay, so that's my collision box. I don't like it. It feels smaller than it should be. I'm gonna make it bigger because I want it to be the full size of my model. So let's just make it a little bit bigger. Okay, my model doesn't seem like centered. So what if I do that? That seems centered. Okay, that seems a lot more centered. All right, if I leave it there, that's gonna make it float. So let's bring this up. So we're still kind of gliding on the ground if that is the collision box. Let's look at that real quick. I think I think that's in a good plot place right there. Yeah. Okay. So let's bring this up a little bit. Oh shoot. Nope. I had the wrong thing highlighted. Okay. Let's bring this up a little bit so that it's slightly above. So we'll make it so it is floating just a little bit. And that way the collision box will be just below it. Because, I mean, it's below. We're not going to, the camera's not going to be below the character. Right? Now, you know what? I do need to make the collision box because I'm thinking about it now. The collision box is smaller than the mesh, or sorry, is the same size as the mesh itself, right? Then that means that whatever logic we have where my character hits the enemy mob, that'll happen without requiring the jump action because it's just a collision at that point, right? I don't know. We'll go with this at first, and if it doesn't work, we'll make the collision box smaller. I think for now that'll work. Sorry, I spent way more time on that than I probably should have. All right, so we brought that up. They said to save it. All right. But first we need to define some inputs. So project. project settings. Where was it? Windows, GUI. Input map, I think is what it was, right? Yeah, input map. At the top, there's multiple things because we did this last time. Sorry about that. All right, so these are the things that we need to add, right? So we're going to add a new action. Um, let's see. Enter. No, I forgot. How do we do this again? The window allows you to add at the top. They are labeled in the bottom part. You can bind keys. Okay. Show built-in actions. Oh. Okay. Those are the built-in actions. KP enter space. Ooh. DualShock? Oh, it's supposed to be writing the name of it. Device 0. Oh, they were just showing that. Okay. Godot projects come with some predefined actions designed for user interface design. See above screenshot. These will become visible if you enable the show built-in actions toggle. I need to read. We could use these here, but instead we're defining our own support gamepads. Leave show built-in actions disabled. We're going to name our actions move left, move right, move forward, move back, and jump. Okay, so move left, right, forward, move back, and jump. All right, so now for left, we want left keyboard key. A. Physical key code. Physical key code. Okay, bind it to A. Let's go ahead and just add the left as well. So here, we're going to the right. So we'll add the right. Oh, no, no, that one. Yep. Oh, it wants us to add joypad axis. Joypad axis. And it says joypad axis left stick 0. Left stick left joystick. That a new Segs toy? It could be. It very much could be. Hey, Diddy. Thanks for stopping by. Select the negative X axis of the left joystick. Negative X axis. Okay. XD free Diddy. Or not. If you look into some of the things he did, that may not have been the best choices. Left stick, right. True, true. Jokes aside. Yeah. Uh, People. Yeah. Never mind. I don't even want to get into that. Let's see. Joy axis 1 left is minus. Oh, that's a joy. Whoops. Wrong button. Joypad axis left stick up, joystick up, negative. Okay. And then move back is going to be S. It's going to be the down button. And we're going to add the joystick of 1 plus for down. Right? Plus all devices. All right. So glad you're doing the dev. If it was me, that input would be named Diddled by Diddy. So many comments. I don't think no, I shouldn't. Uh no, I'm trying to stick to the tutorial as much as possible because when I stray from the tutorials, I always run into problems. So it's like if it breaks now, then I it's most likely the tutorial's problem, or maybe I just didn't read properly. So we're trying that first. All right, the final action is jump. So we want the joypad button, button action Sony cross Xbox A button Nintendo B. Can't be as bad as making kids write their code where all the variables are named spaghetti ingredients. Or every variable is named just an alphabet. It's, yeah. I actually was thinking, I was like, maybe I should also turn some of these streams into just like programming 101. The good old days. Hey, if you want, I can teach data structures and then you could come join my class like 2 or 3 times. Like the good old days. Let's see. Spacebar as well. Okay, so we have jump as a spacebar and the joypad 0. And then we're done. Please do. I have a bunch of people who I could get to join your stream. Just gotta say we're not affiliated. Oh, I'm trying to be affiliated. All right, let's go to the next part. I think if we can get through this tutorial, I think the next stream I really want to focus on trying to come up with a decent idea of a simple, possibly 2D game that we could build in this engine. And then I could post, once we complete it, I can post everything on Patreon. Let's see, moving the player with code. It's time to code. We're going to use the input actions we created in the last part to move the character. We'll be using GDScript. All right, right-click the player node. Attach script. There we go. Let's see. Again, I should probably read. In the pop-up, set the template to empty before pressing the create. We set it to empty because we want to write our own code for player movement. Okay, that makes sense. Let's start with the class's properties. We're going to define a movement speed, a fall acceleration representing gravity, and a velocity we'll use to move the character. Okay, so export var speed. Var fall acceleration. So, I don't know, Dishwasher, if you were here last stream, but as you can already tell, it's like the GD script already takes from JavaScript a little bit, or it has that kind of feel to it. Vector 3, indicating it's a 3D vector. And we're going to use the 0 state. So what this is saying that the target velocity is being initiated at 0, 0, 0. Right. These are common properties for a moving body. The target velocity is a 3D vector combining a speed with a direction. Here we define it as a property because we want to update and reuse its value across frames. The values are quite different from 2D code because distances are in meters, while in 2D, 1,000 units pixels may only correspond to half of your screen's width. In 3D, it's a kilometer. Wow. Okay. Let's code the movement. We start by calculating the input direction vector using the global input object in underscore physics process. Okay, so func underscore physics process. All right. It returns a void. So then we're going to do a var direction is vector 3.0. So start with our 0 state. So now we check if what button is being pressed. Action pressed. Ooh. Move. Start with the move right, because that's what the tutorial is telling me. Direction.x is plus equals 1. So the vector has x and z for directional. Moves. Action pressed. So we move left. Yep, move left. And that direction is dot x. So we're going to minus 1. So we're going to do this for moving back as well. Back. All right, so this is the one. Notice how we are working with the vectors x and z axis. In 3D, the xz plane is the ground plane. Okay. Direction. Okay, and if we notice, again, just like in the 2D plane, or in the 2D game, going backwards, as in going down on the screen or coming towards the screen, is a positive value. Going away from the screen or going up on the screen in 2D is a negative value. Move forward. I don't know why that is, because that would not have been intuitive to me initially. Okay, so that is our physics process. Here, we're going to make all calculations using underscore physics process, virtual function, like underscore process. It allows you to update the node every frame, but it's designed specifically for physics-related code, like moving a kinematic or rigid body. To learn more about the difference between process and physics process, see idle and physics processing. Okay. So essentially, what they're trying to do is break up the difference so that it follows a single responsibility pattern where this function is purely responsible for handling just the physics on a object. So on this node player, the physics is all handled by this one function. Then on another function, process will handle what is happening with the actual character or the node itself every frame, not necessarily the actual physics. So let's see. We start by initializing a direction variable. Then we check if the player is pressing one or more of the move buttons and update the vectors X and Z components accordingly. Sorry. Again, coughing. These correspond to the ground's plane's axis. These 4 coordinates give us 8 possibilities, the 8 possible directions. In case the player presses, say, both WD simultaneously, the vector will move a length of about 1.4. But if they press a single key, it will move a length of 1. We want the vector's length to be consistent and not move faster diagonally. To do so, we can call its normalized method, which is what we did also in the 2D model. So if the direction is not 0, so if we have moved at all, then we want to normalize the direction. Then we do the shortcut of get the pivot node basis, looking at direction. All right, and so then it tells this model or this node to rotate in the direction that we would be moving. All right. Here we only normalize the vector if the direction has a length greater than 0, which means the player is pressing a direction key. All right. We compute the direction the pivot is looking by creating a basis that looks in the direction. Then we update the velocity. We have to calculate the ground velocity and the fall speed separately. Be sure to go back 1 tab so the lines are inside underscore physics process function, but outside the condition we just wrote above. Okay, so they're saying right here. All right, so here our speed is 14 and the fall acceleration is 75. So those are constants, meaning that they will not change. So target velocity dot x direction dot x speed direction dot z times speed. And then if not is on lower. Can't believe there's an actual function for that already. That's so nice. If in the air, fall towards the floor, literally gravity. Target velocity dot y Let's go to target velocity dot y minus the fall acceleration speed times the delta, which is the amount of time that occurs between frames. So the time passing. Then we have to actually update the character. So velocity is equal to target velocity and move and slide. All right, so this velocity is an actual so we have a speed in fall acceleration that we created from the script. So that's a property on the player node. We have on floor. So that'll tell us if we're on the actual floor. There is a velocity. I think it's in form. Motion mode grounded. Well, I know it's somewhere in here because I think I've seen it. So yeah, there is a property somewhere in here for velocity for movement. So this must be the function for actually moving it. All right, so this handles all the physics for the character for moving it. So rotating the character, if you're in the air, you drop it. If you press a movement, it moves the character in the appropriate direction. All right. Character body 3D dot is on floor function returns true if the body collided with the floor in this frame. That's why we apply gravity to the player only while it is in the air. For the vertical velocity, we subtract the fall acceleration multiplied by the delta time every frame. This line of code will cause our character to fall in every frame as long as it's not on or colliding with the floor. The physics engine can only detect interactions with walls, the floor, or other bodies during a given frame. If movement and collisions happen, we will use this property later to code the jump. On the last line, we call character body 3D dot move and slide, which is a powerful method of the character body 3D class that allows you to move a character smoothly. If it hits a wall midway through a motion, the engine will try to smooth it out for you. It uses the velocity value native to the character body 3D. And that's all the code you need to move the character on the floor. Here is the complete code, which is what we have. All right, let's go ahead and save that. All right, we're going to go ahead and test it. We're going to put our player in the main scene to test it. To do so, we need to instantiate the player and then add a camera. Unlike 2D and 3D, you won't see anything if your viewport doesn't have a camera pointing at something. Save your player scene and open up main. All right, if you close the scene before, head to the file system and double click on main. All right, to instantiate, right click on main. Instantiate child scene. Then we grab the player. We open that. Okay. So then now we have the player, directional. All right, let's add the camera next, like we did with our player's pivot. We're going to create a basic rig, click on the main, and add a child node. Create a new marker 3D. Marker 3D. We're going to name it camera pivot. And then add a node to that called camera 3D. Okay. Notice the preview checkbox that appears in the top left of the 3D view when you have the camera selected. We're on script, so 3D. There is a view. Ooh. Okay. We're going to use the pivot to rotate the camera as if it was on a crane. Let's first split the 3D view to be able to freely navigate the scene and see what the camera sees. In the toolbar, right above the viewport, click on View, then two viewports. So you can also press Control 2. Okay, so let's see this again. So View, two viewports. Oh, okay, that's cool. Perspective and perspective. Okay. On here, click that. All right, on the bottom view, select your camera 3D and turn on camera preview by clicking the checkbox. In the top view, make sure your camera 3D is selected. Move the camera about 19 units on the Z axis. Drag the blue arrow. 19. Let's go to just transform. 19. There we go. Here's where the magic happens. Select the camera pivot and rotate it negative 45 degrees around the X axis using the red circle, negative 45. Using the red circle, you'll see the camera move as if it was attached to a crane. Okay, so let's go back to 0. So let's say, okay. You can run the scene by pressing F6 using the arrow keys. All right, F6. Okay. We got movement. We got movement. All right. We do not have jump yet because we didn't actually do that. Ooh. Up we go. Okay, so it is working. It is Squidward. It's the ancestor to Squidward. Okay. So it's working. We can see some empty space around the character due to the perspective projection in the Amoeba Ward. In this game, we're going to use an orthographic projection instead to better frame the gameplay area and make it easier for the player to read distances. Select the camera again, and in the Inspector tab, set the projection to orthogonal. projection. Where's projection? There it is. Perspective, orthogonal. Ooh, shit. What is that? I'm all up in this business. Think I need to move the camera back. Think I need to move the camera back. Only amoebas. All right. Let's see. When using the orthogonal camera in Godot 4, directional shadow quality is dependent on the camera's far value. The higher the far value, the further away the camera will be to see. However, higher far values also decrease shadow quality, as the shadow rendering has to cover a greater distance. If directional shadows look too blurry after switching to an orthogonal camera, decrease the camera's far property to a lower value such as 100. Don't decrease this far property too much or objects in the distance will start disappearing. Okay, this needs to go further away. This needs to go up. Wait, why can't I see anything? All right, let's go back to perspective. All right, that looks the same, right? Select the camera again. Orthogonal. Oh, I missed the second half of that sentence. My bad. Orthogonal. Size 19. There we go. And we run it. Okay. That's not bad. I can see how it's working now. Okay. Wait, how's the shadow looking? Not much of a shadow. Where's the far value? Let's try this at 100. Oh, that's crisp. Yeah, that shadow looks a lot more crisp. Because that was at 4,000. Yeah, look how blurry that shadow is. You can barely see it. So once I drop it down to 100, that's a crisp looking shadow. Okay, I like it at 100. We're going to keep it there. Test your scene, and you should be able to move in all 8 directions and not glitch through the floor. Ultimately, we have both player movement and the view in place. Next, we will work on the monsters. Oh, let's test. Can I go off the screen? I can. Yep, I fell off the screen. So I can do that. Let's go to perspective and then do it again. I want to see it. Whoop! Sorry, that's funny to me. Okay, we're there. All right, moving on. Uh, Sorry, I was reading these comments real quick to see what they were saying. All right, moving on. Designing the mob scene. In this part, you're going to code the monsters, which we'll call mobs. In the next lesson, we'll spawn them randomly around the playable area. Let's design the monsters themselves in a new scene. The node structure is going to look similar to the player scene. All right, so first let's save this. Then we're going to do that. And then we're going to do this. And what did we do? Character body? All right, create a scene. Once again, character, child node with a node 3D, name pivot. Then we bring that in. Okay, so we're just going to try to run through that really quick. And then we need a node 3D, create. That's going to be mob. That's going to be a pivot. And then this is a mob thing. And that is character. Okay. And then here we're going to add a child node of a collision shape 3D, which will be a sphere shape again. Oh, no, they wanted a box shape? Okay, let's change that to a box shape. We should change its size to fit the 3D model. You can do it so interactively by clicking and dragging the orange dots. The box should touch the floor and be a little thinner than the model. Physics engines work in such a way that if the player's sphere touches even the box's corner, a collision will occur. If the box is a little too big compared to the 3D model, you may die at a distance from the monster, and the game will feel unfair. Yeah, yeah, absolutely. Go back to this. Um, so first off, let's raise the pivot model up. That's snapping. It's a snap. That is going through. Here we go. That's what I want. And so then we'll, oh, go back. Now this one, we will bring it up. So let's go ahead and hide this. We're going to bring this all the way up. So it's in line. Come on. Snap to the grid. Snap to the grid. You're not snapping where I want you to snap. Okay, screw it. Just bringing you up a little more. Okay, that seems good enough to me. All right, let's add the character back again. Then let's grab this. That's not the right one. This one. So we are going to go here. Let's open this up to right there. Right here. Let's go right there. And you know what? We'll keep it that like that. That seems fine to me. Yeah. Yeah, that seems good. So if I hit here, 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 or here, then you die. These corners are in the body, so that at least that gives the impression of actually getting hit. Okay, I can dig that. That works. All right. Let's see. What is next? Notice that my box is taller than the monster. It is okay in this game because we're looking at the scene from above and using a fixed perspective. Collision shapes don't have to match the model exactly. It's the way the game feels when you test it that should dictate their form and shape. Removing monsters off screen. We're going to spawn monsters at regular time intervals in the game level. If we're not careful, their count could increase infinitely, and we don't want that. Each mob instance has both a memory and processing cost. We don't want to pay for it when the mob is outside the screen. Once a monster leaves the screen, we don't need it anymore, so we should delete it. Godot has a node that detects that when objects leave the screen, visible on-screen notifier 3D, and we're going to use it to destroy our mobs. Select the mob right here and add a child node of visible. This one? Visibility on-screen notifier. Okay. And so they want us to rename it. Visibility notifier. Okay. Another pink box this time appears when the box completely leaves the screen. The node will emit a signal. Resize it. Using the orange dots to cover the entire 3D model. Okay. Seems a bit large. Seems good enough, right? Fully covered. Yeah, let's go ahead and make it, bring that up. Technically, it really doesn't matter because there is no up down for it. That looks good enough for me. Okay, we're going to attach a script now. Empty template. Okay, so same thing. All right, so now at export bar min speed is equal to 10. Export, whoops, at export bar max speed. Okay, function physics process. And then we're going to do move and slide. All right, similarly to the player, we move the mob every frame by calling the function character model 3D move and slide. This time we don't update the velocity every frame. We want the monster to move at a constant speed and leave the screen, even if it were to hit an obstacle. We need to define another function to calculate the velocity. This function will turn the monster towards the player and randomize both its angle and motion and its velocity. The function will take a start position, the mob's spawn position, and the player position as its arguments. Okay. We position the mob at start position and turn it towards the player using the look at from position method and randomize the angle by rotating a random amount around the y-axis. Below, random f range outputs a random value between negative pi divided by 4 radians and pi divided by 4 radians. That's math that I don't want to figure out. So we're going to do start position, player position. And that's going to pass. Return a void. I'm doing the void thing because I like having it defined that there is no return value, even though it's like the fact that you don't have an actual value in the return does already indicate that it's a void. Oh, these. I think. Do we need to define what these are? Does it not like this? Um, I don't know why that says it's wrong. There's an error. Expecting. Line 5, expected indent block after function declaration. It wants me to actually look at from position. Okay, I needed to actually define something. So if I do that again, it should be fine. Yeah. All right. All right. All right. So we're going to take the start position, the player position, and a vector 3 dot up. One thing that is a little interesting is that these parameters coming in are any's. They're not defined as an actual type, which I absolutely dislike. This is not tightly typed. This doesn't appear to be a tightly typed language at all, which is a bit frustrating. Rotate Y. So rand F. Oops. Yeah, negative. Oh, sorry, rand F range. So negative pi divided by 4 to pi divided by 4. So that will pick a value between those. And then set it to the rotate Y field. All right, we got a random position. Now we need a random speed. Rand I range will be useful as it gives random int values, and we use min speed and max speed. Random speed is just an integer, and we just use it to multiply our velocity. After random speed is applied, we rotate the character velocity vector 3 towards the player. Okay, so far, random speed. So randy range, and then we have our min speed and our max speed. And we take our velocity, and we'll do a vector 3 forward times random speed. All right, I want to clean this up a little bit. That gives us that. And then we need to take the velocity again. And you're going to redefine it with a dot rotated vector up. Rotation dot y. Okay. Let's read through this one more time. Okay, so we read that. We are setting, calculate the random speed, calculate the forward velocity that represents the speed. We then rotate the velocity vector based on the mob's y rotation in order to move in that actual direction. Okay, leaving the screen. We still have to destroy the mobs when they leave the screen. To do so, we'll connect our visible on-screen notifier node's screen exited signal to the mob. So we go to mob, we go to node, we go to... visibly screen exited, connect to mob. Yes. Okay, so we did that. That gives us a new function on the mob. This will add a new function on visibility notifier screen exited. From it, call queueFree method. This function destroys the instance it's called. Okay. queueFree. Our monster is ready to enter the game. In the next part, you will spawn monsters in the game level. Here's the complete code. Okay, so that was actually pretty simple. Next. All right, so now, God, we're only halfway through. We haven't done jumping, squashing, killing, scoring, character animation. And we got about 30 minutes left on the stream, so I think I'm going to have to finish up this stream or this tutorial next week. So that'll be fun. Yeah, that'll be fun. Rushing coding is never a good idea. In this part, we're going to spawn monsters along a path randomly. By the end, you will have monsters roaming the game board. Double click on the main. Okay. Right here. I'm going to go back to one viewpoint. Before drawing the path, we're going to change the game resolution. Our game has a default window size of 1152 by 648. We're going to set it to 720 by 540. A nice little box. Project settings. Okay, where do we do that? Input. We are on input map. Now we want to go to display window and change that to 720 by 540. Exclusive full screen. Okay, I wonder if that's... I'll have to play around with that. That'll be fun. Resizable. Sure. Project size. Resizable. Okay, there's that. And the height to 540. Creating the spawn path. Like you did in 2D tutorial, you're going to design a path to use the path follow 3D node to sample random locations on it. In 3D though, it's a bit more complicated to draw the path. We want it to be around the game view, so monsters appear right outside the screen, but if we draw a path, we won't see it from the camera preview. To find a view's limit, we can use some placeholder meshes. Your viewport should still be split into two parts, right here, with the camera preview at the bottom. If that isn't the case, then do that. Split it into, select the camera node and select preview. Okay, we're there. Okay, let's add the placeholder meshes. Add a new 3D node. Node 3D. Create. And name it cylinders. Cylinders. And then we're going to add a mesh instance. Mesh instance 3D. So then we go down to the inspector, mesh, and we want to use a cylinder mesh. Okay, set the top viewport to the top orthogonal view using the menu in the viewport's top left corner. Alternatively, you can press keypad 7. Okay, orthogonal view. I want to see where that is. View. Top left. Oh, this? There it is. We want top view. Okay. The grid may be distracting. You can toggle it by going to the view menu. Turn that off. Okay. I didn't mean to do that. Control Y. Hey, our bot came back with that updated message. Like I said, I think that I might make the ban on that viewers on star, or at least just viewers on. That's top orthogonal. All right. You now want to move the cylinder along the ground plane, looking at the camera preview in the bottom viewport. I recommend using Grid Snap to do so. You can toggle it by clicking the magnet icon. You could go up. And toggle by clicking or pressing Y. Move the cylinder so it's right outside the camera view in the top left corner. Top left corner. Let's go up. There. Just out of view. Okay, right there. We're going to create copies of the mesh and place them around the game area. Press Ctrl D to duplicate the node. You can also use right click, scene dock, and select duplicate. Move it down the axis. Select both cylinders the copy down. So it's right outside the camera's preview. Select both cylinders by pressing the shift key. Okay. Too far. One over and one up. Okay. Excuse me. Select both cylinders by pressing the shift key and clicking on the unselected one. Duplicate them. Move them so that they're all round. See them. Guess my shadows aren't really picking up on it. They're a bit hard to see when they're white. Let's make them stand out by giving them a new material. In 3D, materials define a surface's visual properties like its color, how it reflects light, and more. We can update all 4 instances, select all the mesh instances in the scene. To do so, you can click 1 and shift and click the last one. Do that. And then we want to click on this. Uh, Expand the material. Assign standard material 3D to slot 0. Empty. Where's material? New standard material 3D. Turning node path? Are these errors? Yeah, those are errors. Click the sphere icon, open the material resource. We can change the color. That's them. Should have moved this back 300. I'm just not getting any shadow off these, which is a little weird. Oh, I'm once I go into the perspective node, I'm getting shadows. Just I want to move the camera just forward and back. I wonder if that's a control move. I don't know. Okay. Whatever. Moving on. I go purple, they went orange. hide it. Nope, not that. Hide that. Okay. We can now use the cylinders as guides, fold them into the scene dock by clicking on the gray arrow next to them. Moving forward, you can use their visibility by clicking on the eye icon next to the cylinders. All right. Add a child node Path3D to main. Path3D. Click on the center of each cylinder. Can I... add point tool, the icon with this. Click on the center of each cylinder, and then close the tool. The center of this one, center of this one, that one, center of that one, and then close the loop. Okay, if any point is a bit off, you can click and drag on it to reposition. That one's a little off. It's hard to like get a good view. Okay, I'm gonna say that that's good. To sample random positions on it, we need the path follow node. Add path follow node to this. Okay. Path follow. So this is spawn path. And this is going to be spawn location. Right click on main node and attach a new script. Oh, wait, I didn't have a main script. Oh, okay. I got confused there. That's why I was like being really quiet and thinking. All right. Extends node. Let's do the export var mob scene packed scene. All right, we first export a variable to the inspector so that we can assign mob or any other monster to it. Likely ban evader restricted. Another one of the hey Darkus. Thanks for doing the ban for me. Appreciate it. Let's see, what are we doing right now? We want to spawn the mobs at regular time intervals. To do this, we need to go back to the scene and add a timer. Before that, we need to assign the mob file to the mob scene property. Otherwise, it's null. Head back to the 3D, select the main node, drag mob tscn from the file system to the mob scene slot in the inspector. So right here. Or I could probably just do a load and just do that. That's probably easier to do. add a new timer node to main. All right, so on main, I got you, homie. I appreciate it. That is what I appreciates about you. All right, F2, we're going to do the mob timer. All right, and then we set these to the wait time of 0.5. And then auto start is on. Let's go ahead and save that. All right, timers emit a timeout signal every time they reach the end of their wait time. By default, they restart automatically, emitting the signal in a cycle. We can connect to this signal from the main node to spawn monsters every 0.5 seconds. The mob timer still selected, head to the node dock on the right and double click timeout. So then we hit the connect here and we want to connect it to main because that's where the script is. So now we have it here. So allegedly, let's code the mob spawning logic. We're going to instantiate the mob scene, sample a random position on the spawn path, get the player's position, call the mob's initialization method, passing it the random position and the player's position, add the mob as a child of the main node. Okay. Let's go ahead and hide those cylinders. We don't need those. So next, on the mob timer, let's go ahead and clear this out. So var mob. So now we can grab or instantiate the actual mob scene. So which the mob scene is an actual mob instance or mob node. Now then, do the mob spawn location. So then you can do the get node, or I believe you can just do... No. I think we have to do get node. Spawn path. Spawn location. Right? Or is there... Okay, so we're just grabbing the spawn location, which is just this thing right here, which is a path follow 3D. So that is a location somewhere on the path 3D that we have defined. So now, spawn location. So then we go ahead and grab mob spawn location dot progress ratio. And F. Okay. This is where I ran into problems in the 2D thing. I don't know why my errors popped up. But we're going to try it again and see if it works. Player position. And then we get the player character or player node. Player dot position. And then we're going to instantiate the mob. Or sorry, initialize the mob. Meaning that we call the actual function from the script. And we're passing in the starting position, which we which is defined from the spawn path spawn location. And then we grab the player location. Now, if you wanted to shorthand this, you don't actually have to set it to a variable. I think we could just do this player dot position. Do something like that. But let's just go ahead and follow the tutorial. And then we add the child. Ooh, child, not child, as a mob. All right, so let's read through these notes or comments in their code. So the first one is create a new instance of the mob scene. Then we choose a random location on the spawn path. We store the reference to the spawn location node right there. And then we give it a random offset. Then the player position, we grab that. And then we actually initialize the mob using the actual function right here, initializing it. And then we spawn the mob by adding it to the main scene. So, save it. All right, above rand f produces a random value between 0 and 1, which is what the path follow node's progress ratio expects. 0 is the start of the path, 1 is the end of the path. The path we have set is around the camera's viewport. So any random value between 0 and 1 is a random position alongside the edge of the viewport. Note that if you remove darkest, interesting using pathing to determine random starting location. Yeah, that's they use that both in the 2D and 3D. And I believe you can actually do a looping for how the actually I need to look into it. If you have a set path that you want a enemy to follow as well. But yeah, I think it's pretty cool. If you want it like completely randomized in a way. Let's see. This above gives an error because there is no player. Here is the complete code above. Oh, sorry. Note that if you remove the player node, this thing, the main scene will error out. Obviously, we have to have a player in it. There's a code. You can test it by pressing F6. All right, let's test it. Ooh. You can. Oh no. Oh no. There's no logic. There's no logic when it runs into things. Just mob on mob on mob. Oh no. It was working though. I wonder, can I just do an escape for the input? Exit. Yep, never mind. So let's try that again, just to look at it. Whoa, the speeds is randomized, so you get a couple fast. I like how they just slide around like that. Okay, I'm done goofing off about that. Got a few more minutes left. So let's see. What is jumping and squashing? Let's see. Community making suggestions. All right, jumping and squashing. Let's see how long this portion is. You know what? This might be a good stopping point right now. It's like we've got the mobs, we got the player, we have the main scene. They're all created. I can actually delete. It doesn't say to, but I'm going to delete the cylinders. Actually, no. Let's just leave it there for now. since the cylinders kind of like help us identify where the viewport is in a way. So, everyone take a shot whenever to say. Yeah, I think we made some decent progress. We created a player with a collision box on it and a pivot using whatever this is. Which this is just a no 3D using a Blender object, basically. And then we have a script on the player, which on this player, it takes the input of moving around and then also understands that if we're in the air, then we adjust the velocity for coming down. We've also created the mob character right here, which also follows pretty much the same as the player, except it has a visibility notifier. So when the mob exits the screen, we can immediately destroy that asset or that node, and then we don't have to keep that resource running. So that's done within the script. So we also run this physics process on the character, and so or the mob, and this move and slide just basically tells it to move every single frame. The function initialize is what we're calling in main, and that turns the mob in the direction of the user or the player at the time of instantiation or at creation, at spawn, picks a random speed between 10 and 18, and then starts moving in that direction. So that's where the physics underscore process occurs. And then on visibility notifier screen exited, that's the signal that comes from the visibility notifier when it exits the screen. That signal kicks off, and then so on the mob signal, it'll receive that signal and then call this queue free, which will destroy the node. And so then in main, we created, let me take it out of to view and then top or go back into perspective. So what we did here is we created a ground mesh instance that it matches the collision shape itself. We added a directional light so that we have shadows, and we adjusted the far distance on that camera, or sorry, we did that on the camera. We also added a camera right here and put it in orthogonal view and adjusted the far distance so that way the shadows right here are a little bit more crisp. Added the player to it, and then we added the cylinders around the corners using the dual view ports. That way we could identify what is technically outside the viewport itself. And then that allowed us to create the actual spawn locations, the spawning path. So you click 3, and then you click this button to close the loop, and that becomes a just complete loop right there. And then you add the spawn location, which is a path follow 3D, which is a point along this path. So the start point and the end point is right here. And so any point along here is a percentage, is a value between 0 and 1. And then we have a mob timer, which is used to create our mobs based off our script right here. So we made it that far so far. That far so far. Okay, we made it that far in the tutorial. So what we have left is the jumping and squashing of the player. Then we have a way for the player to die. Then we need the UI to keep track of the score and for the game to be able to restart. That path spawning could let you do cool stuff like using a sign function instead of random to spawn waves or something. Yep. It's a good point you mentioned that, Dargus, because when you go through the community notes through the tutorials, especially on like the first 2D game, players did mention that as well. Or sorry, devs did mention that as well, how they used sine and cosine and how they modified the spawning and even the timing for how it's done. So it's a little bit more powerful than you would think, which is actually really cool, and it's fairly simple to pick up. And as I mentioned early on, it's like the language, the GD scripting language within Godot is very reminiscent of TypeScript, for me at least. JavaScript, because it is definitely not type safe. I mean, you can make it type safe, but for the most part, it's not required. So, yeah, there's that. Everything's just a var. So, that will be the end of today's tutorial that we're working through. Oh, type safe should be a best practice then. Yeah, absolutely. I agree. So then next time we will cover the jump, squashing, killing our player, the UI, and being able to restart the game, and character animation, apparently. Additional character animation. So that will be it. Thank you so much for stopping by. Hopefully, I will see you next week as well. Oh, and on a side note, if we get through the rest of this tutorial pretty early next stream, we'll spend the rest of the time trying to come up with a basic diagram of what we would want to do for a simple game that we can just design on our stream. Maybe a shooter, a very 2D shooter in pixel art, maybe something else. We'll focus mostly on free assets because I am not an artist. So there's that. Anyway, thank you so much for stopping by. Thank you for everything. And hopefully I will see you next week. Until then, have a wonderful weekend and keep it simple. Play some games. Bye.